Hi everyone, this video is going to cover some graphing of quadratics. This is your challenging version. If you haven't already watched the easy version of graphing quadratics, those quadratics were in a form that could be factored. This is the harder version of those. So these are quadratics that are in standard form, which cannot be factored, where you'll have to complete the square or use the axis of symmetry formula to solve them. So again, if you haven't watch the easy version of this video, I would go back and watch that. But if not, let's go ahead and get started. So this quadratic is x squared plus 2x plus 3. Normally, we want the number to multiply to 3 and add up to 2, and then we can just factor it and use our factored form to make our graph. In this case, there isn't anything that multiplies to the number 3 and adds up to the number 2. So we have to complete the square in order to graph this. There is one other way to do it using the axis of symmetry formula, and I'm going to show you both ways in all of these examples, okay? So let's start with my first version, which is completing the square. So to do this, we'll rewrite this as y equals x squared plus 2x plus a blank plus 3 minus a blank. So I'm including these blanks in here because if I add something here, I can actually make this equation factorable. So right now I can't factor it, but if I fill in the blank with the proper number and corrected number, I can factor it. And in addition to that, if I add that number, I will need to subtract the number to keep this equation balanced. So you can think of it as you hand your friend $10, that friend owes you $10, so they have to give it back to you. So if I hand them something, they have to give it back to me. So if I add something, I have to subtract it. Hopefully once I show you an example, this will work out. So you can go ahead and reference the completing the square video if this is a little complicated for you, because I do have an in-depth tutorial of how to do this if this is your first time seeing this. But I'll go over it kind of quickly. Essentially, when we add the blank, what we're doing is we're saying, well, something needs to multiply to x squared and add up to 2x, but we don't know what's going to go in this bottom blank yet to make it factorable. When we complete the square, we want the top of our factor square and the side of our factor square to be identical. So essentially what I'm saying is we want the same number on the top and the side to add up to the number in the corner, the 2. So of course, the same number on the top of the side that adds up to 2 is going to be 1 and 1, because 1 and 1 is the only way we can add up to 2. And when we do 1 and 1 multiplied together, we get 1 in the bottom corner. 1 times x will give us 1x. 1 times x will give us 1x. They add up to 2x. So this is completing the square. And the goal with completing the square is to get the side and the top to be identical, okay? So we are going to need to add the number 1 into our blanks, okay? So it's going to go in the first blank, we're adding it. And if we add 1 to this equation, we also need to subtract 1 to keep it balanced. The reason we're doing this is because we can change this to vertex form, because these 3 terms, this trinomial, is this factor square. And we can replace x squared plus 2x plus 1 with the x plus 1 times x plus 1 because we already have it there, right? So that's the factored version. So it can be x plus 1 times x plus 1. And then we had positive 3 minus 1 left over. So that will be plus 2 on the end. Now, whenever we have the same thing repeated, so these are binomials and it's the same thing, we can actually just go ahead and square it. So we can say y equals x plus 1 squared plus 2. So essentially, we took this equation, we added and subtracted a chosen number by completing the square. In this case, it was the 1, so we have to add it and subtract it. Then we rewrote our trinomial, so the first 3 terms, with the factored version from our factor square. Just as a quick note, a trick to doing this without the square is to do half of your b value, your middle number, and square it, right? So half of 2 is 1, and 1 squared is 1. That's what's going to end up in that blank right there. We rewrote that as x plus 1 times x plus 1, which is the same thing as x plus 1 squared. Left over, we had plus 3 minus 1, and that's what gave us the minus 2 in the back. Okay, now we have this equation in vertex form. And when an equation is in vertex form, we're very comfortable with graphing it, right? We can identify the vertex very quickly. So our vertex comes from this value and this value. Remember, what's with your x needs to change signs. So our vertex, instead of being positive 1, we have to make it negative 1. The y value, the positive 2, stays positive. So your vertex here is going to be negative 1, positive 2. So from the center, you can go back 1, up 2, and plot your point. Of course, we don't have a listed coefficient here, meaning there's an invisible 1 of our coefficient. So our pattern about the vertex table only needs 2 columns, and it will be x and x squared. So we can move left and right 1 square, left and right 2 squares, left and right 3 squares, and left and right 4 squares, up 1 square, up 4 squares, up 9 squares, up 16 squares. Obviously, we can't plot all that on this graph. Let's plot what we can. From my vertex, which is the point on the graph, I can go left or right 1 square from my vertex and up 1 square from my vertex to make my U-shaped parabola. After that, I can go left and right 2 squares from my vertex, up 4 squares from my vertex. And plot my points. And then, of course, left and right 3, up 9 is going to go off the graph, so I can stop right there and draw in my lines and arrows. So that's what my graph looks like. Now, there is another way to do this that might be a little bit simpler for some of you. I'm going to do that in this dark green color, okay? So this is complete, this is finished, this is correct. We completed the square to get it into vertex form so we could graph it. The other way of doing this is by using the axis of symmetry equation. Now, the equation for the axis of symmetry actually comes from part of the quadratic formula. It is negative b over 2a, okay? Negative b over 2a is your axis of symmetry. So just as a reminder, your a value is what's in front of your x squared, b value is what's in front of your x, and c value is your constant. That's the number that's on its own. So it goes ax squared plus bx plus c. So in this case, our b is 2. So that's going to be what's on top. And our a is 1. I know it's 1 because I have one singular x squared there. And the 1's invisible because we don't have to say that's 1x squared. There's only 1x squared there, so the 1 doesn't need to be written. We can plug in our 2 for our b, our 1 for our a, and we can get our equation for our axis of symmetry. So let's do that. We can say negative b, so negative 2 over 2a, and a is 1. Of course, this is going to be negative 2 over 2, and negative 2 over 2 is negative 1. So this right here is our axis of symmetry. Now, I'm going to go back to our graph. I'm going to erase what we have and show you that this is going to make the same graph, okay? So if I draw in my axis of symmetry, it will be at negative 1. And remember, it matches on either side. That's what axis of symmetry means. So x equals negative 1. I know that my axis of symmetry is always where my vertex is. So the x value of my vertex is going to be negative 1 every single time. This is going to be the x value of my vertex. You can look at our previous work and you'll see that is definitely true, the x value of my vertex. Now, pretend I didn't do any of that work in red, right? So right now, if I was starting this problem, the green part, all I have is a line at negative 1. I have no idea where my vertex is on that line. It could be up at 9, it could be down at negative 7, it could be anywhere on that line. So what I'm going to do is I'm going to find the y value of my vertex. And to find the y value of my vertex, I just take the x value of my vertex and plug it into my original equation. So my original equation is up here. y equals 1x squared plus 2x plus 3. If I plug in -1 into that equation, I will be able to find the y value of my vertex, okay? So that's what I'm going to do. I will have y equals, this is going to be -1 squared plus 2 times -1 plus 3. Now, you might notice I put -1 in parentheses before I squared it. That's important, particularly if you're using your calculator. If you do not put it in parentheses, it will give you an incorrect answer. So we need to make sure we're squaring the whole -1, not just the 1 and leaving the negative out, if that makes sense. So -1 squared is going to give me -1 times -1, which is +1. So we're going to have +1. 2 times -1 is -2. And then we'll just have a +3 on the end. Our y value is going to be 1 minus 2. So 1 minus 2 will be -1 plus 3. So -1 plus 3 is going to give us a +2. So the y value of our vertex is +2. So I calculated the x value of my vertex using the axis of symmetry equation. This is a formula. And then I plugged the x value of my vertex into my original equation to find the y value of my vertex. So at this point, I know that my vertex is at -1, 2. So I can plot -1, +2. That's the same place that the previous problem had it. So I know I'm doing this correct. Now, from here, I need to figure out how my graph is going to behave. Of course, we already know that it's going to open upward. It looks like a regular quadratic, but pretend I didn't already know. The way that I figure out how this graph is going to behave is I look at my a value, right? There's no coefficient listed in my original equation. Therefore, the coefficient of this is 1. And whenever I have no coefficient listed or a coefficient of 1, my pattern about the vertex table is just x and x squared. So I can do left and right 1, left and right 2, left and right 3, and left and right 4. And I can go up 1, 4, 9, and 16 to make my graph. So I'll do the same thing here. And I have an identical graph to that red one we did using the different method. So both of these methods are entirely legitimate. Completing the square is one way to graph these, and using the axis of symmetry equation is another way to graph these. It's up to you to determine what you want to do. For the rest of this video, I'm going to show several more problems, and I'm going to show both methods for you to use, okay? So you just use whatever you are comfortable with, whatever you understand, and neither way is wrong. Both ways are correct. So again, just use your judgment for what you want to do. All right, here is our second one. Of course, you know that there's no number that multiplies to -1 that adds up to -6. So this is a not factorable quadratic. When we don't have a quadratic we can factor, we either need to use the axis of symmetry equation or we need to complete the square. I'm going to start by completing the square. I'm going to say y equals x squared minus 6x, add a blank, subtract 1, and subtract a blank. You are welcome to make the square in the bottom or off to the side to make this make sense to you. But just as a reminder, to fill in the blank, all you have to do is half of this number squared. So half of -6 is -3, and -3 squared is 9. So I'll add 9 and subtract 9 from this. Now, if I were to put that in a box, I'll show it super quick. It'd be x squared, which is x and x, adds up to -6x. We would actually do -3 and -3 to multiply to 9. That's why we're using the half value. So we can replace x squared minus 6x plus 9 with x minus 3 times x minus 3, which is the same thing as x minus 3 squared. So that covers all three of these. That's the same thing as the factor square I have over here. And then left over, I have -1 minus 9, which is -10. So from here, I know my vertex is going to be 3, -10. So just as a reminder, always change the x value. And I know my coefficient is 1 because I don't have anything listed. So again, when my coefficient's 1, my pattern about the vertex table is just going to give me x and x squared. So I'll go left and right 1, left and right 2, left and right 3, and left and right 4, up 1, up 4, up 9, and up 16. Let's go ahead and graph it. We're going to start at 3, negative 10. That's right here. I'll go left and right 1 square from the vertex, up 1 square from the vertex. So I'll be here and here. Left and right 2, up 4. Left and right 3, up 9. Left and right 4, up 16. Then when I'm finished with that, I can draw in my lines and my arrows in my parabola to finish my graph. So again, we completed the square in order to make this graph. If you prefer the other method, I'll go ahead and use the other method, and I'll make a little squiggle here so we can say we're restarting, and we're going to use the axis of symmetry equation. And what I'm going to do is I'm going to plot the equation I make in green using the axis of symmetry on top of my red graph that I already have here that I found by completing the square, so you can see that it'll give you the same answer. So if you want to use your axis of symmetry equation, you can do negative b over 2a. Remember, it's ax squared plus bx plus c. My b is going to be negative 6. So whenever you're subtracting, that means that b value is going to be negative, okay? So I will have a negative 6. That will become a positive 6 over 2a. And if I have nothing listed here, my a value is 1. So I'll have 2 times 1. So negative 6 is going to give me positive 6. 2 times 1 gives me 2. And 6 divided by 2 is 3. You can see that matched the vertex that I found when I completed the square. So this is the x value of my vertex. It's like that every time. Axis of symmetry is the x value of my vertex. I can go ahead and draw in my line, my axis of symmetry, just so I can see it on the graph, so I can see where my vertex is going to end up. My axis of symmetry is x equals 3. Now that I have the x value of my vertex, to find the y value of my vertex, I will plug in 3 for x, and it should give me my y value. So I'll have 3 squared minus 6 times 3 minus 1. To be clear, I put it in my original equation. I put 3 into my original equation. 3 squared is going to give me 9. Negative 6 times 3 gets me negative 18. And then bring down my negative 1, so minus 1. 9 minus 18 will give me negative 9. Negative 9 minus 1 will give me negative 10. So my y value of my vertex is going to be negative 10. Now that I have my x value and my y value, I can say that my vertex will be at 3, negative 10. So 3, negative 10. I can see that my a value is 1, so that means my coefficient is 1. I'll only need 2 columns in my pattern about the vertex table, and it should follow the same pattern. Left and right 1, up 1, left and right 2, up 4, left and right 3, up 9, and left and right 4, up 16. You can see all my points were identical with my red line, and I can draw in the exact same shape for my graph found by using the axis of symmetry equation. All right, let's do a few more. This is going to be slightly more challenging. And the thing that makes this problem more difficult is because there is a coefficient of 2. So my coefficient is my a value here, and my a value is 2. This will make the shape of the graph skinnier. Whenever you have an integer coefficient, your graph is vertically stretched out, and it will be slightly thinner than one with a coefficient of 1. So completing the square is also going to be different as well. If you need a refresher on that, please go back to that video to make sure you feel confident. But we're going to go ahead and work through this one both ways, with the axis of symmetry formula and by completing the square. Let's start by completing the square. So we are going to add a blank, move over our constant, and then subtract a blank from the end. Now, you'll notice on the previous two, I just had an x squared, and on this example, I have a 2x squared. The extra step you need to do here before halving that middle number and squaring it to fill in your blanks is to pull out the greatest common factor of the first two terms. The greatest common factor of 2x squared and 12x is going to be 2. So we're just going to pull out the number, not the 2x. I know obviously both of them share an x, but we're just taking that biggest number out. This is the same thing as pulling out your coefficient. So my coefficient on this one is 2. I'm going to pull the coefficient out in order to get this equation into vertex form. So let's go ahead and do that. I'll say y equals 2 times x squared minus 6x plus a blank, close my parentheses, plus 9 minus a blank. So to be clear, I divided this term and this term by 2, pulled it out front, and then reset my blanks so that I am not attached with a coefficient to my first term, to my x squared. Now that my x squared is isolated, it's by itself, there's no more coefficient, I can take half of my middle value, so half of negative 6 is going to be negative 3, and square it. Negative 3 squared is going to give me positive 9. It looks like I added 9 to this equation. I know it looks like that, but I actually didn't add 9 to this equation. I added 18 to this equation. Hopefully you can see that because I pulled this 2 out, if I were to distribute, I'd have to multiply that 2 back in. So I actually added 2 9s to the equation for a total of 18 added to the equation. We can go back to that analogy. If you give your friend $9 twice, they owe you $18. So you didn't just give your friend $9 one time, you gave your friend $9 two times. So that is why it's $18. So your friend owes you $18 back. Hopefully that makes sense. Okay. Now that we have determined what our blanks are, we can go ahead and finish completing the square. We'll have y equals 2 times x minus 3 squared, and then minus 9. I got the x minus 3 because half of this value is negative 3, and then I got the minus 9 because 9 minus 18 is negative 9. If you need to complete the square to do that, feel free to do that. This is going to be the vertex form of my equation. Hopefully you can see now why I pulled that 2 out, because that 2 is now clearly my coefficient. So my vertex is going to be positive 3, negative 9. And my pattern about the vertex table will have 3 columns, and the third column will have my coefficient of 2. So it'll be x squared, and 2x squared. I can go 1, 2, 3, and 4, up 1, 4, 9, and 16. And then I multiply my center column by my coefficient of 2 to figure out my y movement. So 1 times 2 will be 2, 4 times 2 will be 8, 9 times 2 will be 18, and 16 times 2 is going to give me 32. Once I have my third column made, my center column no longer matters. Typically, I like to scratch it out so I don't get confused. You can do anything you want with it. And I can go ahead and graph this. I'm going to start at my vertex, which is at 3, negative 9. From there, I'll go left and right 1 square, up 2 squares. Left and right 2 squares, up 8 squares. Left and right 3 squares, and up 18 squares. That's all I'm going to be able to fit. Perfect. You'll notice this graph is a little bit skinnier than the two we did previously. That is because of our coefficient of 2. All right, let's go ahead and show the other method, which is using the axis of symmetry equation, and we'll do this one kind of quickly. Our axis of symmetry equation is negative b over 2a. My b value is negative 12, so this will be negative 12 over 2a, and my a value here is 2. Negative 12 is positive 12. 2 times 2 is 4. 12 divided by 4 is going to give me 3. So this here is the x value of my vertex. So I can draw in my axis of symmetry at 3. Then to figure out where my y value is, I'll plug in 3 for x. So I'll get 3 squared minus 12 times 3 plus 9. 3 squared will give me 9 here. So y equals 2 times 9. Negative 12 times 3 will give me negative 36. Bring down my plus 9. I'm going to do 2 times 9, and 2 times 9 is 18. So 18 minus 36 plus 9. 18 minus 36 is negative 18, plus 9 is going to give me negative 9. So y equals negative 9. That is the y value of my vertex. And now that I have my x value and my y value, I can confidently say my vertex is at 3, negative 9. Now, going back to my original equation, I look at my a value to determine my movement. So my pattern about the vertex table will be x squared, and 2x squared. I'll go left and right. 1, 2, 3, 4, up 1, 4, 9, 16, and of course multiply those by 2. And I can make my graph. It'll make the same shape. So my vertex is at 3, negative 9. Left and right, 1 up 2, left and right, 2 up 8, and left and right, 3 up 18. You can see it matches my red graph. So just to reiterate, you obviously don't have to do both of these methods. Just use the method that works best for you. My preference is actually the red one. I like completing the square better, but a lot of students find that it's easier just to use the formula because it'll work every time and it's pretty simple, kind of foolproof. So it's up to you. Again, don't feel like you have to do both of these. I know it's a lot of work. I'm just showing them both so you have some options, okay? Let's do another. Again, we have another coefficient. So our coefficient here is going to be 2. That's our a value. Let's go ahead and complete the square. We are going to say y equals 2x squared plus 4x plus a blank plus 6 and minus a blank. Let's pull off our 2. That's our coefficient. So the 2 will come out front. 2x squared divided by 2 will give us x squared. 4x divided by 2 will give us 2x. We leave our blank in our parentheses, do plus 6 and minus a blank outside our parentheses. To fill in that first blank, we'll do half of our middle number squared. So half of our middle number is 1. 1 squared is, of course, 1. It's secretly not a 1. It's actually a 2 because 2 times 1 will give us 2. So if I gave my friend $1 2 times, that friend owes me $2 back. So if I added $2 to this equation, I need to take $2 out of this equation. So I'm subtracting 2 on the end. Next, I can replace my 3 terms with x and then half of my middle number and then put a squared at the end. So x plus 1, because half of 2 is 1, squared. Left over, I have positive 6 minus 2, which will give me plus 4. And now my equation is in vertex form. So my vertex here will be negative 1, 4, and my pattern about the vertex table will have 3 columns, just like last time. My coefficient's 2, so I'll have x squared, and 2x squared. So I'll go 1, 2, 3, 4, 1, 4, 9, 16, and 2, 8, 18, and 32. No longer need that middle column. Let's go ahead and start at my vertex, which is negative 1, positive 4. I will go left and right 1, up 2, And I can't fit left and right 2 up 8 because I have a very thin graph. It's nice and skinny. So I will just draw my arrows from that vertex. If you want to do this using the axis of symmetry equation, let's go ahead and do that. Our A value is going to be 2, and our B value is going to be 4. So axis of symmetry is going to give me negative B over 2A. So I'll say negative 4 because my B value is 4. My pen's giving me a little bit of trouble. Sorry about that. There we go. Sorry, I just had to reset my pen there for a minute. My apologies. So negative B over 2A. Let's try that again. We'll do negative 4 over 2A, and my A is 2. This is going to give me negative 4 over 4. And my x value of my vertex is going to be negative 1. So axis of symmetry will be here at negative 1. I will plug in negative 1 into my equation to find the y value of my vertex. So I'll do negative 1 squared plus 4 times negative 1 plus 6. Negative 1 squared is, of course, 1, and 2 times 1 will give me 2. 4 times negative 1 is negative 4, and then I got to bring down my 6. So I'll have 2 minus 4 plus 6, and my y value is, of course, going to be 4. So my vertex will be at negative 1, 4. So I'll start at negative 1, positive 4. I can look back at my A value. So obviously I'll have this table when I build it. It'll be x squared, and 2x squared. And I can go left and right 1 square up 2 squares. All right, let's try another one. And then at the end, I'm going to have a bonus, which is a little bit complicated. You're actually going to be able to factor this last one. So hopefully you like it. It's another hard problem. So though it doesn't match the same pattern as the ones we've been doing, it's really useful. And I think it's going to help you be successful seeing that problem. All right, we have a slightly bigger coefficient. Our coefficient's 3. So the bigger the coefficient, the skinnier our graph gets because it's getting stretched and stretched and stretched vertically. Let's go ahead and start by completing the square. So we'll say y equals 3 x squared minus 6x plus a blank minus 5 and minus a blank. Then I can go ahead and take my 3 off of it. So I'll have 3x squared. This will be negative 2x plus blank minus 5 and minus a blank. Now to fill in my square, I do half of my middle number. My middle number is negative 2 squared. So negative 1 will be half of my middle number. Squared would be 1. It's not actually a 1. It's actually a 3 times 1. So it's a 3. So I'll subtract 3 from the end. Next, I can say y equals 3 and then x minus 1 squared. And that minus 1 is half of my negative 2. Then I have negative 5 minus 3. So it's going to be minus 8. My vertex here will be positive 1, negative 8. And my coefficient is going to be 3. So I will have x squared, and 3x squared. So I'll go 1, 2, 3, and 4, 1, 4, 9, and 16. And then I'll do 3, 12, 27, and 48. I no longer need that middle column. Once I have this set up, I can start at 1, negative 8, go left and right 1, up 3. Left and right 2, up 12. And I will have my graph. All right, let's show it the other way. Super quick, we're doing our axis of symmetry equation, which is negative b over 2a. My b value is negative 6, so I'm going back to my original equation. So negative 6 over 2a. My a value is 3. Obviously, negative negative 6 will give me a positive 6, and 2 times 3 will give me a 6. 6 out of 6 is just 1. This is the x value of my vertex. So I can draw a dashed line for my axis of symmetry at x equals 1. So my axis of symmetry is x equals 1. Now I can plug in that 1 into my original equation in order to figure out the y value. So again, I'm plugging in the 1 as my x value. 1 squared is, of course, 1. 1 times 3 is just 3. Negative 6 times 1 is negative 6. And then bring down my negative 5. Negative 6 and positive 3 will give me negative 3. Negative 3 minus 5 is negative 8. So the y value of my vertex is negative 8. My vertex is going to be 1, negative 8. Of course, I already have that plotted, but that's where it will be on my axis of symmetry. Then I can go back and look at my a value. My a value is my coefficient. And I could make the same table as I have right there. I'm not going to rewrite it just for the sake of time, but you could rewrite it yourself if you were doing this method. I'll go left and right 1, up 3, left and right 2, up 12 from my vertex. Again, that movement is off of my vertex. Okay, those are the main hard ones. Now I've included one more just to show you that you can use this axis of symmetry equation in different contexts. So let's go ahead and look at it. This one looks a little bit different because it's missing the c value on the end. I will show you my first recommendation for solving this is actually going to be for you to factor it. This is factorable. So we can factor it because our greatest common factor between these two terms is 2x. See how they both are divisible by 2? And both terms have an x in it? That means you can pull a 2x out. So I'll say y equals 2x times x minus 2. So just to be clear, I divided this by 2x. 2x squared divided by 2x will leave me with just an x. And I divided negative 4x by 2x. So that cancels out my x, and I'm left with negative 2. Now I can use the zero product property by making my y equals 0 to find my two x-intercepts. So I can say 2x equals 0 and x minus 2 equals 0. If I divide 0 by 2, I'm still got nothing. So my my x-intercept is going to be 0, 0. That's my first one. And then my second x-intercept will be at 2, 0. So I'll start one at 0, 0, second one at 2, 0. Of course, if we are working through this, this is what we did on the easy version. So you should be familiar with this after watching that video. We can draw in our axis of symmetry, and our axis of symmetry will be right in the middle at x equals 1. We can make a table here, and our pattern about the vertex table is going to be x squared, and 2x squared. And that 2x squared comes from my coefficient, which is right after my equal to sign here. I can fill in my table just like normal. Remember, you are multiplying the middle column by your coefficient of 2 to get it. So if I was 1 square away from center, which on each of these I'm 1 square away from center, I can work backward. And that means I had to have gone up 2 from my vertex to find those points. So to work backward, I can go back down 2 to get to my vertex, which will be right here. From there, I can go left and right 2, up 8. And draw in my final points that'll fill in this graph. Oh, sorry, that one's on the wrong spot. There we go, like that. Nope, the original one was right. Sorry, there we go. So I went left and right 2, up 8 for that last one. Perfect. Okay. The reason I'm showing you this example in this hard video is because I want you to be comfortable with using this axis of symmetry equation for kind of an odd looking problem. The axis of symmetry equation will still work here. So we can say our axis of symmetry is negative b over 2a. So this will be negative negative 4 over 2 times a, which is 2, which will give us positive 4 over positive 4, which is 1. So this is still the x value of our vertex. Even though there's no c value, you can still do the same thing. plug that into your original equation, 4x, to find the y value of your vertex. Obviously, 1 squared is 1. 1 times 2 is 2. So this is going to be 2. And then negative 4 times 1 is negative 4. So this will be y equals negative 2. So my vertex here will be at 1, negative 2. Boom, 1, negative 2. That's where I'm at, exactly. Then I can go back to my a value of 2 and make my same table that will match what I have right here in order to make the rest of the graph. So you can actually use this axis of symmetry equation in multiple different places. But I wanted to just show you, if you can factor it, even with the greatest common factor, go ahead and factor it, because I think it's the easiest method, just to use your x-intercepts and work backward. And this axis of symmetry equation is very friendly, and you can use it in a lot of different places. Anyway, thank you again for listening. If you need to go back, you can go back to that easy quadratic functions. I'll have that linked. And then also the completing the square video, I'll have that linked as well.